Laboratorium Struktur Material dan Produksi Bangunan Laut, Kantin FTK, Musola FTK, Ruang Baca Departemen Teknik Kelautan. Selain itu, Departemen Teknik Kelautan memiliki program studi pascasarjana yang meliputi magister, S2, dan doktoral, S3. Dan masing-masing telah terakreditasi oleh Badan Akreditasi Nasional (BAN PT). Berikut adalah informasi lengkapnya. Berikut adalah prestasi-prestasi mahasiswa Departemen Teknik Kelautan. Selain fokus mengembangkan bidang akademis, Departemen Teknik Kelautan juga memiliki banyak kegiatan yang berlatar belakangkan sosial masyarakat. Mahasiswa lulusan Teknik Kelautan juga tersebar di seluruh perusahaan besar di dunia. Hal ini membuktikan Departemen Teknik Kelautan melahirkan orang-orang yang berkompeten pada bidangnya.
Assalamualaikum warahmatullahi wabarakatuh. Departemen Teknik Kelautan ITS berdiri sejak tahun 1983. Sudah menghasilkan banyak alumni dan berkiprah selama kurang lebih 37 tahun. Departemen Teknik Kelautan ini terdiri dari 3 program studi, yaitu program studi S1, program studi S2, dan program studi S3. Di masa yang akan datang, Departemen Teknik Kelautan menjadi lembaga pendidikan tinggi rekayasa kelautan yang bertaraf internasional dan menjadi tujuan di Asia Tenggara dan lebih dikenal di tingkat internasional. Diharapkan mahasiswa di tingkat nasional banyak berminat untuk studi di teknik kelautan, sehingga bisa dihasilkan raw material yang lebih baik dan akan dihasilkan sarjana, magister, dan doktoral yang semakin berkualitas.
The world keeps evolving. The times keep changing. The new generation of technology. The new generation of information. They bring the future before us. Institut Teknologi Sepuluh Nopember, a place where the spirit of heroism underlies the new generation to research and innovate in technology. The University of Heroes, ITS. ITS is one of the best science and technology universities in Indonesia, which was founded by Dr. Angga in 1957. In every step, ITS focuses in advancing education, research, management, and community service. As an incorporated public university, ITS has been able to manage autonomously the policy of academics, organizations, finance, students' affairs, human resources, facilities, operational, and infrastructure.
In the spirit of Indonesian heroes, during the battle in the 10th of November 1945, ITS always makes efforts to be the best in education, research, and community services, especially in the fields of industry and maritime. ITS also actively contributes to the nation development, and in the future, ITS will become an entrepreneurial university with world-class reputation.
ITS has many achievements. Both national and international achievements prove that ITS keeps growing and gives the best contribution to the nation of Indonesia. ITS is a place for new hopes to grow. An ideal environment for the new generation to flourish in 3 strategic locations within the industrial city of Surabaya. As a smart eco-campus, ITS maintains harmony between technological advances and the sustainability of the surrounding ecosystem. ITS has 7 faculties with prospective scientific fields, including Scientists, Insis, Vocation, Creatis, Martech, Electics, Plan. ITS is a space for the new generation who are hungry for knowledge because it provides a wide range of references in both physical and digital form. ITS makes it easier for the new generation to access information by providing flexible classes. ITS keeps moving forward in facing future challenges by providing the best facilities for the new generation's activities. The facilities support both spiritual and physical needs. ITS also provides research facilities in the ITS Science Technopark, including ICT and robotics, automotive, maritime, and creative industries. Therefore, the excellent generations from ITS will emerge and make history. ITS is a space for the new generation to express themselves. ITS is a place where the new generation learns new things and finds their purpose. ITS has become a place where the new generations that carry the future will be born.
ITS is a campus of science and technology, which focuses on the research and innovation, presenting technology for prosperity.
With a spirit of heroism, ITS brings the future before us. ITS, the University of Heroes.
Institut Teknologi Sepuluh Nopember berdiri sejak tahun 1960 oleh Dr. Angka Nitisastro. Kemudian dilakukan penandatanganan oleh Bapak Presiden pertama Indonesia, Insinyur Soekarno. Pada tahun 2020, oleh THE Asia University Rankings, ITS mendapatkan peringkat 3 sebagai perguruan tinggi terbaik di Indonesia. Dijuluki sebagai kampus maritim, ITS memiliki fakultas yang berkonsentrasi pada bidang kemaritiman, yaitu Fakultas Teknologi Kelautan. Departemen Teknik Kelautan Institut Teknologi Sepuluh Nopember Surabaya merupakan program studi tertua di Indonesia dalam bidang teknik kelautan, sehingga menjadikan Departemen Teknik Kelautan sebagai Center of Excellence di bidang offshore dan coastal engineering, baik di level Indonesia maupun level regional ASEAN. Departemen Teknik Kelautan ITS berdiri sejak tahun 1983, yang mana pada saat yang bersamaan nama Fakultas Teknik Perkapalan berganti nama menjadi Fakultas Teknologi Kelautan, tepatnya pada masa kepemimpinan Profesor Insinyur Sugiono. Departemen Teknik Kelautan mendapatkan akreditasi A dari Badan Akreditasi Nasional Perguruan Tinggi dan telah diakui secara internasional oleh The Royal Institution of Naval Architecture yang berbasis di London, Inggris, dan akreditasi internasional dari Indonesia Accreditation Board for Engineering Education. Departemen Teknik Kelautan memiliki 6 bidang keahlian, Di antaranya, bidang keahlian material dan produksi bangunan laut, bidang keahlian perancangan dan struktur bangunan lepas pantai, bidang keahlian hidrodinamika lepas pantai, bidang keahlian teknik dan manajemen pantai, bidang keahlian energi dan lingkungan laut, bidang keahlian rekayasa bawah air dan laut dalam. Berikut adalah fasilitas penunjang mahasiswa teknik kelautan. Laboratorium Infrastruktur Pantai dan Pelabuhan, Laboratorium Rekayasa Hidroinformatika Kelautan, Laboratorium Lingkungan dan Energi Laut, Laboratorium Konstruksi Bangunan Laut, Laboratorium Hidrodinamika Bangunan Laut, Laboratorium Struktur Material dan Produksi Bangunan Laut, Kantin FTK, Musola FTK, Ruang Baca Departemen Teknik Kelautan. Selain itu, Departemen Teknik Kelautan memiliki program studi pascasarjana yang meliputi magister, S2, dan doktoral, S3, dan masing-masing telah terakreditasi oleh Badan Akreditasi Nasional (BAN-PT). Berikut adalah informasi lengkapnya. Berikut adalah prestasi-prestasi mahasiswa Departemen Teknik Kelautan. Selain fokus mengembangkan bidang akademis, Departemen Teknik Kelautan juga memiliki banyak kegiatan yang berlatar belakangkan sosial masyarakat. Mahasiswa lulusan Teknik Kelautan juga tersebar di seluruh perusahaan besar di dunia. Hal ini membuktikan Departemen Teknik Kelautan melahirkan orang-orang yang berkompeten pada bidangnya.
Assalamualaikum warahmatullahi wabarakatuh. Departemen Teknik Kelautan ITS berdiri sejak tahun 1983. Sudah menghasilkan banyak alumni dan berkiprah selama kurang lebih 37 tahun. Departemen Teknik Kelautan ini terdiri dari 3 program studi, yaitu program studi S1, program studi S2, dan program studi S3. Di masa yang akan datang, Departemen Teknik Kelautan menjadi lembaga pendidikan tinggi rekayasa kelautan yang bertaraf internasional dan menjadi tujuan di Asia Tenggara dan lebih dikenal di tingkat internasional. Diharapkan mahasiswa di tingkat nasional banyak berminat untuk studi di teknik kelautan, sehingga bisa dihasilkan raw material yang lebih baik dan akan dihasilkan sarjana, magister, dan doktoral yang semakin berkualitas.
Selamat siang Bu Silvi.
Ya, selamat siang Pak Dekan. Terima kasih Pak Trika sudah datang.
Ladies and gentlemen, we cordially invite you to turn on your camera because in a few minutes the opening ceremony will proceed in no time. Good morning, ladies and gentlemen. My name is Natasha Keniraras and I am your host today. It is our privilege to have you with us. I would like to welcome all of you to the 8th International Seminar on Ocean and Coastal Engineering, Environmental and Natural Disaster Management, ISOCEEN 2020. This event is held by cooperation among Institut Teknologi Sepuluh Nopember, ITS, especially Department of Ocean Engineering, Tohoku University, Japan, TU Delft, Netherlands, UNESCO IHE Delft, Netherlands, and HZ University of Applied Science, Netherlands. The papers contained in these proceedings cover the topics including the field of ocean, offshore, coastal engineering, environmental and disaster management. It is an honor to me to inform you that among us here, we have Rector of the Institut Teknologi Sepuluh Nopember, Professor Dr. I.R. Muhammad Ashari, Master of Engineering. ISOCEEN 2020 Chairman, Associate Professor Suntoyo, PhD. Senior Director of International Activities Center, IAC, Japan Society of Civil Engineering, JSCE, Tohoku University, Japan. Professor Doctor of Engineering, Hitoshi Tanaka. The keynote speaker, Associate Professor Doctor of Engineering, Ahmad Sana, from Department of Civil and Architectural Engineering, Sultan Qaboos University, Oman. The keynote speaker,
Associate Professor Alvaro Semedo, PhD, from IHE Delft, Netherlands. The keynote speaker, Associate Professor Tan Sri, Dr. Muhammad Faris Hamidi, from College of Engineering, Qatar University. The first invited speaker, the Vice President of Tuy Loy University, Vietnam, Professor Dr. Engineering Nguyen Trung Viet. The second invited speaker, Senior Lecturer of the Department of Maritime Technology, Faculty of Ocean Engineering Technology and Informatics, University Malaysia Terengganu. Associate Professor IR, Doctor of Engineering Ahmad Fitriadi. The head of HAPI Indonesia, Dr. IR Irwandi, Master of Science and the Secretary of HAPI Indonesia, Professor Dr. IR Dietrich G. Bengen, DEA. The purpose of this forum is to create and expand the professional network to foster the relationship between the university, industry, business, and communities across the globe. The main agendas of this event are opening speech, presentation by keynote speaker, discussion, parallel session, and closing ceremony. Ladies and gentlemen, to start this event, we will listen to the national anthem Indonesia Raya and continue with the ITS hymn. Let us start the event. As the chairman of ISOCEEN 2020, Associate Professor Suntoyo PhD will be delivering the welcoming speech. Ladies and gentlemen, please welcome Mr. Suntoyo.
Bismillahirrahmanirrahim. Alhamdulillahirrabbilalamin. Good afternoon. Presence of Allah Subhanahu wa Ta'ala, a grace that has given favor and gift in this afternoon. The first that we respect, Rector of ITS, Professor Muhammad Azhari, Dean of Faculty of Marine Technology, Dr. Eng Tri Kapitana, Head of Department of Ocean Engineering, Dr. Hirman Pratekno, and Senior Director International Activities Center, Japan Society of Civil Engineering, Professor Dr. Eng Hitoshi Tanaka, representative of Indonesian Coastal Management Expert Association, and also Indonesian Coastal Engineering Expert Association, distinguished keynote speakers, and Professor Dr. Eng Hitoshi Tanaka from Tohoku University, Japan, and Associate Professor Ahmad Sana, PhD, from Sultanate Kabul University, Oman, Associate Professor Alvaro Semedo, PhD, from ISE UNESCO, the Netherlands, Professor T.S. Dr. Muhammad Faris Kamidi, Qatar University, Qatar, and invited speakers, Professor Dr. Eng Nguyen Trung Viet, Vice President, Tu Loy University, Vietnam, and Associate Professor Dr. Eng Ahmad Fitriadi from University Malaysia, Terengganu. Lecturers within ITS, contributing authors, seminar delegate, expert, scholar, all students, ladies and gentlemen. Welcome to the 8th International Seminar on Ocean and Coastal Engineering, Environmental and Natural Disaster Management, ISOCEEN 2020. I am pleased to join here today. We are collected to announce that this international seminar was initiated by a collaboration between ITS, especially Department of Ocean Engineering, and Tohoku University. At the time, Professor Hitoshi Tanaka initiated a conference or seminar, and together with my colleague from Tohoku University. And that have collaboration since 1997. In the year of the 2006, a memorandum of understanding, MOU, has been signed and then extended between Tohoku University and ITS, especially Department of Ocean Engineering. And to promote further collaboration between two universities, many activities that have performed will, in terms of collaborative research, faculty and student exchange, joint educational program, seminar, and etc. Especially for the seminar and workshop has been done before. For example, the Japan-Indonesian workshop on estuary and climate change on either 2010. However, the previous seminar activity organized not regularly or annually. Therefore, since 2013, has been held an annual seminar entitled the first international seminar on ocean, coastal engineering, environmental and natural disaster management, ISOCEEN, November 11, 2013 at Surabaya, Indonesia. With the increasing amount of cooperation between Indonesia, Japan, Netherlands, and other countries, then this forum is more focused on creating and expanding professional network to foster the relationship between the university, industries, business, and communities across the countries. This year, again, we are proudly to announce that ITS, in collaboration among the Tohoku University Japan, ISE Netherlands, University and Applied Sciences Netherlands, Novik International Education Netherlands, jointly organizing the 8th International Seminar on Ocean, Coastal Engineering, Environmental and Natural Disaster Management. Within webinar or virtual seminar in Department of Ocean Engineering, Faculty of Marine Technology, Institut Teknologi Sepuluh Nopember on 27 to 28 October 2020. This seminar also supported by Indonesian Coastal Management Expert Association and also Indonesian Coastal Engineering Expert Association. In this seminar, with 4 keynote speakers, 3 invited speakers, and 55 regular talk contributions from over 120 participants from 12 countries, namely Indonesia, Japan, Netherlands, Oman, Qatar, Germany, Portugal, Spain, Vietnam, Malaysia, and Korea. And participants of this seminar come from 14 foreign universities and 12 domestic universities, 6 research center or agency for the assessment and application of technology, 4 overseas research center. Selected paper will be presented in the ISOCEEN 2020, will be published in the IUP conference series, Earth and Environmental Science, Index in Kampus. Finally, on behalf of the organizing committee, the seminar, I would like to warmly thank all the authors who, with their presentation, generously contributed to the lively exchange of the scientific information that so vital to the endurance of the scientific conference of this kind. And special thanks are also due to all keynote speakers and all committee for the effort in preparing the manuscripts and managing the session respectively. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much, sir. Next, as Director of the Institut Teknologi Sepuluh Nopember, Professor Dr. I.R. Muhammad Asyari, Master of Engineering, will be delivering the opening speech. Ladies and gentlemen, please welcome Professor Muhammad Asyari.
Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Very good afternoon, ladies and gentlemen. Welcome to ISOCEEN 2020. The Honorable Dean of Faculty of Maritime, Dr. Trika Pitana, the Honorable Chairperson, Dr. Suntoyo, and also the Honorable Head of Ocean Engineering Department, Bapak Herman Pratikno, PhD, the Honorable Senior Director, International Activities Center, IAC, Japan Society of Civil Engineering, Professor Hitoshi Tanaka. Good afternoon, but probably late afternoon for you, another 3 hours behind Indonesia. And distinguished keynote speakers, Professor Hitoshi Tanaka as well, Associate Professor Ahmad Sana from Sultan Qaboos University, Oman, also Professor Alvaro Semedo from UNESCO, Delhi, Netherlands, Professor Muhammad Faris Hamidi from Qatar University, also all invited speakers, and also senior leaders and lecturers and researchers who attending this conference. It is great pleasure to meet you in this international conference, the 8th or after 8 years international seminar on ocean and coastal engineering, environmental and natural disaster management, ISOCEEN 2020, that this is the 8th of the seminar. It's good pleasure. It's very thank you for Department of Ocean Engineering of ITS that can maintain this conference, this seminar with a very good keynote speech, expertise with diversity countries, as mentioned by the chairperson, Dr. Suntoyo. I wish to warmly thanks to the host of this dedication and preparing the importance of international seminar in this event. As we know, the international conference, international seminar like this conference, it's very helpful to improve the international environment in ITS. As we know, ITS, Institut Teknologi Sepuluh Nopember, 10 November means 10th of November. There was a big battle in Surabaya in 1945 after Independence Day. This we use as the name of this university. This university, ITS, was established in 1960. It was ceremony by the first President of Indonesia, Insinyur Soekarno. And this university, ITS, was established especially dedicated to support the maritime of Indonesia. And until now, up to now, we still very strong in maritime, in ocean engineering, that the host of this conference today. Now, ITS will, I think next month, we will have a 60th anniversary of ITS after establishment. And we are happy that this conference, this seminar is part of our celebration of 60th anniversary of ITS. And today in ITS, we have 7 faculties, 20,000 students, 1,000 faculty members, and then the position of ITS in the world university ranks according to Times Higher Education. The position in Asia is 200.1. In Indonesia, the position is ITS is the 3 best university according to Times Higher Education. Ladies and gentlemen, all distinguished participants, we hope that this forum, this seminar, is more focused on creating and expanding professionalist network to foster the relationship between the university, industry, business, and government. As I mentioned, our university ITS is very strong in maritime, in ocean engineering. We already serve to design, to improve, to provide many ship, many vessel for government requirement. until now, we still serving many kind of vessel or ship or maritime asked by the Minister of Transportation of Republic Indonesia. So we hope that this conference will fruitful to improve, to invent, to innovate any technology regarding the maritime. Not only maritime, but also the environment, the sustainable science and technology onshore, ocean, and also coastal engineering. Finally, I would like to express our gratitude to all speakers, all distinguished keynote speakers, invited speakers, and all committee for contributing in our seminar. Special thanks are also for all invited speakers and committees for the effort on preparing the manuscript and managing the session respectively. Thank you very much. Happy seminar, happy conference. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much for Mr. Muhammad Ashari for your very delighting welcoming speech. Before entering first session speech, we will have a quick photo session. To all audience, please turn on your camera. Thank you very much for your cooperation. Now, this is the time for us to enter the first session speech from our keynote speakers. We are very privileged to have him as our first guest speaker today, Professor Doctor of Engineering Hitoshi Tanaka, Senior Director, International Activities Center, IAC, Japan Society of Civil Engineering, JSCE, Tohoku University, Japan. The second speech will be delivered by Associate Professor, Doctor of Engineering, Ahmad Sana from Department of Civil and Architectural Engineering, Sultan Qaboos University, Oman. This session will be guided by Professor I.R. Widi Agus Pratikto, PhD, as the moderator. To Professor Widi Agus Pratikto, the stage is now all yours.
Thank you, the MC. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
I'm sorry for the dynamic of the background because sometime on, sometime off. But we try the best that we provide with the background of the ISOCEEN. First of all, the first session will be first speaker, Professor Hitoshi Tanaka, the Senior Director of International Activities Center. I think we were having a long partnership with him. And the second one will be Associate Professor Dr. Ing Ahmad Sana. I think that will be served for from 13:14 up to 14:15. That means 1 hour. So you might have like 15 minutes or 20 minutes each, and then that will be question and answer. I will be happy to have Professor Hitochi coming first, delivering his speech. Time is yours, Prof. Hitochi.
Yeah, thank you very much for your kind introduction of myself. And Selamat siang, distinguished guests, ladies and gentlemen. Good afternoon. It is my great honor to give a lecture here. And first of all, I'd like to express my grateful thanks to Dr. Suntoyo for his kind invitation. And also, I wish to celebrate 60th year anniversary of ITS. Okay, so let me share the. Can I share my PPT file? It is not allowed. Someone responsible for this connection? I cannot upload. Okay, now it is. Can you? Is it okay? Yes. So I need to start my lecture. My talk today is the sea bottom boundary and very shear stress and tsunami. As you all know, we had a very serious and devastating tsunami disaster in Japan about 10 years ago. And as you can see here, there was a very serious disaster in Japan. And similarly, in the year of 2004, the Indian Ocean tsunami occurred in Indonesia. So we are sharing the same natural disaster due to tsunami. So that's why I took this topic for my keynote lecture. So this is one typical erosion in Japan along the Sendai coast. Before the tsunami occurrence on March 12, we had a very smooth shoreline, very nice environment along the coast, but it was seriously damaged by tsunami. And after some time, there was a recovery process along the coast, but it's still, even now, in some places, more serious impact is remain along the coast. And I'd like to introduce numerical simulation for such a morphology change induced by tsunami. It is very, very common to use the shallow water equation to make a numerical simulation for tsunami. And from that hydrodynamic modeling, we can calculate bottom shear stress. Then coastal morphology change can be predicted using numerical model. But there comes a question about numerical simulation. As you can see here, the wave hydrodynamics can be classified into short period wave and long period wave. And for the latter, we can use shallow water equation, but we don't know what's the corresponding friction factor for tsunami wave, right? We simply assume that for long wave, because it is long wave, we can use a steady friction factor, as you can see here on this slide. But no one knows whether demarcation will be located here or here. And there's a possibility that even under long wave motion, the steady friction factor cannot be used. And there come the scientific questions: how to define the demarcation criteria for friction law under tsunami, and clarify the characteristic of boundary layer and the bottom shear stress beneath tsunami waves. This is a motivation of our research activity for this topic. And this is a diagram I just took from the textbook for undergraduate student. And as you all know, for steady flow, we can use this kind of friction factor diagram, which is commonly called the Moody diagram. Although it has been initially proposed for circular pipe flow, but it can be applied for open channel as well. And normally we use the Manning and which is equivalent to rough turbulent friction factor in this diagram. And as you all know, there's a totally different friction diagram for wave motion, right? And for example, for rough turbulent regime, we have totally different represented lengths. There is a AM. There is a water particle excursion length and a wave motion. So like that, comparing a steady friction factor and the wave friction factor, the representative length is totally different, whether it is water depth or the amplitude of water particle excursion length. So the problem here is how to define the demarcation criteria for friction law, whether steady friction law or wave friction factor under tsunami numerical simulation. Before I explain the detail of this research, let me introduce the tsunami-induced morphology change in Japan. First of all, let me introduce the devastating morphology change on Rikuzen Takata coast. As you can see here at the top, the pre-tsunami situation was like that. Very nice sandy coast with the very dense pine tree forest in this area. But as you can see at the bottom, the sandy coast as well as the pine tree forest disappeared completely due to tsunami. And at some place here, there is only one pine tree remained after tsunami. This pine tree is called miracle pine, a lone pine tree that stood as a symbol of hope. So there was a project to recover this sandy coast. Of course, due to natural process, it is impossible to recover the sandy coast. So we had a project of recovering sandy coast. And not only sandy coast, but also constructing the embankment, as you can see here, which has a height of more than 10 meters. Because in this area, tsunami height was more than 10 meters. So that's why the height of the embankment is about 12 meters. And as I mentioned, the sandy coast completely disappeared. So they made a plan to create a beach again. And also plantation of pine tree on the sandy coast. And this is the plan of beach nourishment in this area. And not only the sandy coast, but also immersed breakwater has been reconstructed. Even after the tsunami, we had immersed breakwater, but it was seriously damaged by tsunami. And in our technical committee, we made a detailed discussion what kind of sand can be used for beach nourishment, and making a comparison between original sand and borrowed material. We decided to use the sand, as you can see here, which had the similar diameter and a similar color as compared with the initial sediment. And embankment construction has already finished. The height is more than 10 meters. And as you can see at the bottom, the beach nourishment has already completed. So this was a very, very big project. And let me introduce some other examples of serious beach erosion. As you can see here, there was a very serious erosion. But very interesting on the left-hand side, almost no change. Even during so extreme tsunami, only the right-hand side of the sandy coast was seriously eroded. According to our detailed investigation, this is due to difference of structure. I will skip the detail of this explanation. And this is another example of very serious erosion. As you can see here, very serious breaching happened on the sandy coast. But gradually, with the passage of time, the natural recovery happened. And like this, it took more than 2 months for the complete recovery on the sandy coast. This is another serious erosion on sandy coast. And longshore sediment is moving from the right to left, and due to tsunami, a very serious erosion. But after some time, recovery happened. But too much sediment supply caused the complete closure of the river mouth. That was another the problem, a natural disaster in this area. So as you can see here on the right-hand side, a gradual shoreline advancement happened after serious erosion on this coast. As you can see here on the left-hand side, the sediment was eroded on the both sides of seriously eroded area, and very serious retreat on both sides, on the right-hand side and the left-hand side can be seen because the sediment was supplied to the eroded area, in the concave shaped area. Okay, this is another example of serious erosion, but I will skip the detail. This is another place with very serious erosion of river mouth sunspit, and even now, nothing happened. Even now, the river mouth is totally open without sediment deposit. So like that, after tsunami, there are many various response in many situations. And here, it is very, very serious problem of no recovery of sunspit at river entrance. This is also a very serious place. As you can see here, on the right-hand side at the top, there was sandy coast and a very dense the pine tree forest, but it completely disappeared, very seriously eroded. According to the field survey in this region, the maximum water depths induced by the serious erosion by tsunami attained to more than 10 meters, something like that. Right? So even now, almost no recovery. And this is showing the numerical simulation result. As you can see here, very high tsunami propagated along the river that caused a very, very serious erosion, especially in the sandy coast near the river mouth. This is a aerial photo before tsunami and after tsunami. The very gradual, very slow recovery can be seen. And even now, the situation like that. On the right-hand side, this is the most updated morphology. I show almost no recovery of the sunspit at the river entrance. Like that, still very, very serious problem remain in many places. Okay, now I'll come back to our study about tsunami-induced bottom structure. I explained already about this diagram. We know the demarcation between the short period wave and the long period wave, but we don't know where demarcation is for friction law. So that is our motivation of the present study. And there are two scientific questions. What is the demarcation, and what is the characteristics of the bottom boundary layer and the tsunami? So let me make a brief literature review of this topic. In the past computation, it is very common to use Manning or wise buffer F for numerical simulation. And although it is a long parallel way, the flow motion is fundamentally the unsteady. So no one knows whether steady friction factor can be applied or not. And in 2016, the research group in the Teknologi University of Denmark made a detailed numerical simulation for tsunami boundary layer using K omega turbulence model. And they found that the tsunami boundary thickness is about 1 meter, which is very small as compared with the water depths. So that means the steady current friction factor can be utilized for tsunami. And there have been several the studies for solitary wave boundary, including ours, and we found that the unsteady characteristics is highly predominant even under long wave. And this is a brief introduction of our study. In this diagram showing the water depth variation from the tsunami source area. The left-hand side is the tsunami source area with a depth of 4,000 meters. And we input the tsunami wave at this end, and we calculate the tsunami propagation process from the left to the right. And this is the computed boundary thickness. As you can see here, tsunami boundary thickness is very, very thin as compared with the water depth, which is 4,000, right? This is a ratio between the boundary thickness and the water depth. It is very, very small. That means the steady friction factor cannot be used. And with the propagation of the tsunami to the onshore direction, tsunami boundary layer developed, and also water depth decreased gradually. So this ratio come to the value about 1.0 near the shoreline. And this is showing the comparison between the boundary layer from the wave theory and that from Manning's method. As you can see here, Manning's N underestimate shear stress under tsunami. This is a very, very important fact because shear stress or shear stress induced wave energy attenuation affect the wave height of tsunami, and also sediment movement induced by tsunami. So this is a very, very important result in connection with the tsunami disaster prevention planning. Yeah. And the motivation in our study is what friction law need to be used in tsunami numerical or simulation. In shallow water area, there must be boundary layer development or up to the water surface. Okay, so we can use the steady flow or friction factor such as Manning or wise buffer, whatever. But in deep area, how to evaluate the bottom shear stress? That is a big problem clarified from our previous study. So in our study, we use the K omega turbulence model for hypothetical shoring tsunami. It's a bit complicated mathematical equations for K omega model. Anyway, we use this model in a vertical direction to obtain the velocity profile under tsunami. And in the tsunami source area, we are showing that the tsunami height is 1 meter, and the water depth is 4,000, and wave period is 15 minutes. And for tsunami shoring process, we can use the very, very well-known Green theorem, as you can see here. And also tsunami-induced velocity can be calculated using the linear shallow water theory, as you can see here. And according to this equation, the velocity under tsunami is inversely proportional to water depth. So if we have so deep water depth as 4,000, the tsunami-induced velocity will be very small, right? And in our numerical model, we assume this grain size, which is 0.3 millimeter on the bottom, and we made a detailed numerical simulation for these 4 cases for water depths of 4,000, 1,000, 100, and 20 meters, getting shallower and shallower to the direction of shoreline. And this is a very, very well-known diagram for applicability of wave theories, deep water wave, intermediate wave, and shallow water wave. And this indicate the breaker line for wave motion. And as you can see here in this diagram, our 4 cases, from case 1 to case 4, belong to long wave, because water depth or wavelength ratio is smaller than 0.05, and under these 4 conditions, the wave height is much smaller than the breaker limit. Okay, I will show for numerical simulation result. This is a computation result for offshore boundary. That is a tsunami source area with a depth of 4,000. And as you can see here, the velocity profile is shown here, and the vertical axis is normalized by water depth. As you can see here, the bottom boundary area is confined in immediate vicinity to the bottom, right? And when we use the Manning end, we assume that the velocity profile might be similar to open channel flow, but as you can see here in this diagram, velocity profile is totally different from that in open channel flow. And because of this velocity profile, the Manning end steady friction factor gives the too much underestimated shear stress. Right? According to our computation, the about 6 times difference as compared with the steady flow or estimation. This is very, very important that using the Manning end, we will underestimate the wave energy or dissipation process. Okay, now let's come to the water depth of 1,000, which is located somewhere here. In a computational domain, it is rather shallow area with a depth of 1,000, but still the boundary layer is located in the immediate vicinity of the bottom. So resulting in the underestimation of the bottom shear stress, as you can see in this diagram. Very big difference between steady computational result and our computational result. Even at the 1,000 water depths, such a big difference can be seen. Okay, next we come to the water depths of 100, very close to the shoreline, but still the boundary layer thickness is about 1% of the water depth, resulting in the underestimation of shear stress using the steady friction law. Okay, now let's move to the most shallow place, which has the 20-meter water depth. But still, the underestimation of shear stress can be seen using the steady friction factor. So like this, even up to the location of 20-meter water depth, the Manning end cannot be used for tsunami numerical simulation. This is a very important new finding from our study. And
Prof. Tanaka,
yes,
your time is up.
Okay, so then finally,
yes, please.
Okay, so finally I will conclude my presentation. Important result is that in the shallow area, the steady friction law can be used, but in a deeper area, it cannot be used. And yeah, our four cases belong to this area in which shallow water equation can be used, but the steady friction factor cannot be used. Okay, thank you for your kind attention. This is the end of my talk.
Thank you very much. We appreciate for the paper. Ladies and gentlemen, Professor Tanaka have title Tsunami Induced Morphology Change due to tsunami. So please, if you have any question, we still have up to 1:47. So we have couple minutes for discussion and question. Time is yours. Please raise your hand or using the what you call it, chat or something, or might be mentioning to the MC, the moderator. I mean the facilitator. Thank you. Is there any?
Excuse me for Professor Widi.
Yeah.
Excuse me, Prof. Widi.
Yeah.
For the next session is for the keynote speech session for Associate Professor Dr. Ahmad Sana first, and then we'll be continued to discussion session.
Oh, okay. You didn't tell me. So I was thinking once is Professor Tanaka, then 10 minutes for question. Otherwise, then I will proceed for Prof. Ahmad Sana. Time is yours for giving 20 minutes for material and then 10 minutes or so for having question and discussion. Time is yours, Prof. Sana.
Thank you very much, Professor Vidi. I would like to thank my dear friend and previous colleague, Professor Suntoyo. And also I see my supervisor, Professor Tanaka here. So very hard for me to speak in front of him, but anyway, I shall try. So let me just present my presentation here. Okay, I can share. Okay. I hope everybody can see my screen. So the topic today that I want to talk about is the measurement of seawater quality and hydrodynamic parameters along the coast of Oman. That was actually a funded project from the Ministry of Environment and Climate Affairs. Now it is called as the Environment Authority in Oman. This work was jointly done by a lot of members from our research team and our recent doctoral degree graduate, Prerna Chitrakar. She finished her PhD using the information that I'm going to present today. So she worked on the data analysis. Of course, data gathering was a big task. So it was a teamwork, but she did most of the analysis that I'm going to present today. First, I will just talk a little bit about Oman. And as like a lot of people, they might not know because it's a small country just on the eastern edge of Arabian Peninsula. The reference, of course, can be given by Kingdom of Saudi Arabia, which is on our west side. And northern side, northwest side, we have United Arab Emirates. And in the south, we have Yemen. So these three countries are, of course, very well known. And in Oman, we have about 11 what they call as regions, governorates, they call them. And out of these 11, 7 of them are actually having coastline. So a lot of activity on the coast. The length that has been measured by different scales is of the order of 3,000 kilometers. And we have, as you can see, let me just try to use my pointer. So as we can see here, this part at the tip of the this Oman Sea and Arabian Gulf, we have Musandam, that is also part of Oman. In between, we have UAE as well. So this is briefly about Oman. We have very small population, about 4 million. Area is quite large considering the Arabian countries. So it's like 309,000 square kilometers. We have just to show you a little bit of interesting bathymetric features here nearby. So we have here Sea of Oman, previously known as Gulf of Oman. And we have here Arabian Gulf or Persian Gulf. It depends on from where you are speaking. So if you are from Iran, then definitely you would call Persian Gulf. If you are sitting in an Arab country, then you will be calling it as Arabian Gulf. Here we have Oman, and we can see very interesting features here in the bathymetry. So the depth here is like of the order of 3,000 meters, and it within about 300 to 400 kilometers, it reaches about 40 meters. So very steep slope when the seawater actually enters or leaves the Arabian Gulf here near the Musandam Peninsula. So this is a Strait of Hormuz. I hope everybody knows about it. Here we have some other interesting features, which are like one of them, Murray Ridge, which is very famous here in this region. Then Dalrymple Trough is also there. So they affect the circulation in this area. So a lot of these features are interesting here. Here we have somewhere here, Indus enters into the sea, and this whole area is like the sediment, mainly it is coming from the Indus River. So this is the name of this area. They have named it as Indus Fan. Then there are some interesting circulation features which are taken by the satellites. So here we have Ras Al Had jet, which is very famous circulation feature in this area. They call it Ras Al Had front as well. There are two big like gyres, eddies, which are here, and the circulation pattern actually shows in this map. In fact, the chlorophyll A concentration is shown, which was taken by the satellite image. This image I have taken from NASA's website. So here, as we can see here, very strong presence of dense chlorophyll A near the shoreline. And actually, when we did some measurements, we also found similar features in our coastal measurements, because most of our measurements are near the coast. So here, like just in this figure on the right, it shows some of these features which I just talked about. Then the measurements, like of course the measurements were supported by the government, and they are interested to have like permanent monitoring facilities along the shoreline. They wanted to have some baseline measurements along the shoreline, especially where some of the existing structures are, which can cause environmental problems. So we chose these 12 stations. Most of the activity is actually on this coast, which is northern side, which is called as Al-Batina coast. There are a lot of activities here from coastal engineering point of view. Then we have recent activities here at Dukum, a very big port has been constructed. There is a dry dock and a refinery as well. Shuemia is like a kind of so far is a kind of passive area from a development point of view, but there are going to be planned activities in future. Taka is again is a very active area here. There are a lot of coastal structures and coastal establishments are there. So a lot of activities in all these points. So that was actually one of the consideration while selecting these measurement points. So I'm sorry, because of the time and because of the space, I probably there will be some confusion. So, but I can answer the questions later maybe. So I will just rapidly go towards what we have done. As I said, these are the pictures from our selected areas. So all these areas, in fact, they have some coastal features. So whatever picture you see there, we have located one of the measurement points there. The major activities, as you can see, they are either shipping ports or the fishing ports. There are desalination plants and power plants as well, like a combination of power and desalination. That is mainly in Barka area. Then we have Al Ghubra desalination plant as well. We have some aquaculture in the open ocean near Kuriyat. So we have done some measurements there as well. There is a fishing port also. In Muscat area, which is close to Muscat, is Mina Al Fahl area, where we have the biggest refinery of the country. And we have a lot of activities, port activities here. Then we have Dukum, as I said, that's the new port which has been constructed, just completed within a couple of years. And then we have Taka, which is in the south. We have some ports, fishing ports, as well as desalination plant and power plants there. Shuemia, as I said, is so far not many development has been taken place. So this point could be like considered as one of the control points, which like in the natural environment. So the equipment, of course, is well known. This is the boat that we used. This belongs to our university. It's a small vessel, research vessel that we have. We deployed the current meters. The current meters was basically from Nortec. We had about 4 units, so we deployed them at various places, and we kept them for generally for about 2 to 3 months, but a few places we kept them for longer duration in the sea. Here you see the CTD as well. So CTD was used for the in situ measurements of some of the water quality parameters, but we took samples as well and we brought them to lab and we analyzed them there. So all these activities, of course, we took samples with respect to depth in the near the top and in the middle and in the kind of bottom, by using this water bottle, where we can control where the sample has to be taken. Some of the parameters that we measured here and how we analyzed them, that is like some of the simple measurements were like temperature, salinity, dissolved oxygen, chlorophyll A. These were measured in situ by using CTD. And all the other things like, for example, EC values. Of course, EC was in situ also, we measured it, but we did BOD, COD, and most of the other like water quality parameters were done in the lab using the equipment there. The biggest trouble, as we know, that is heavy metals, because they have very small or very low concentration in seawater. So for that, we had to use ICP OES. So like some of the equipment that our university has. Some of the, of course, I'm sorry, it's a lot of data and a lot of abbreviations as well, but I will try to just highlight the features that are important in my view. Of course, I shall be able to answer other questions later. So Ghubra, as I said, there is a desalination plant, so temperature in this area is generally, it is high. But of course, I cannot 100% say that because of the weather or the time in during the year, because some of the measurements were in the summer, some of them were in winter season. But in general, like we can see that close to the desalination plant, we had higher salinity, we had higher temperature. Similarly, for dissolved for EC, similar pattern, because of course salinity is dependent on EC is dependent on salinity. Uh, of course, for the chlorophyll A, Dukum area is we found high values there, and I shall talk about it a little bit later, that what could be the reason. But one of the factors that we have seen before in the NASA image, that near the coastline in that area, they have reported higher chlorophyll normally in that situation. So dissolved oxygen in general was good, but it's kind of serious in some of the places where it is less than 2 milligram per liter. And if it is below 2 milligram per liter, then the aquaculture is actually in a big trouble. Like marine animals, they start dying if the dissolved oxygen is much less than 2 milligram per liter. So in some of the places we had this situation. Similarly for BOD, then again BOD is found to be higher near Kurayat, and in Kurayat, as I have shown before, that there is aquaculture activities going on. So that could be the reason for this higher values. Similarly, the phosphorus, which is again related to the waste of marine waste. In other areas, of course, we can see that these water quality parameters are not that high. Total coliforms in Sohar area were more, which shows a little bit of presence of the wastewater. And similar is here, like for the E. coli, we found higher concentrations near Sohar area. These are some of the profiles of temperature which were done by CTD. Some of them, they were done in winter, like February, and some of them were done in summer or spring. So as we can see here, in interesting features, of course, we can see close to Barka area, as well as Ghubra area, where the desalination plants are there. So we have very nice stratification. In the upper layers, the temperature is quite different from the lower layers. In general, in lower layers, the temperature ranges from 24 to 26 degrees, whereas the top layers, we have water ranging based on the season. It can be up to 30 or 31 degrees. Similarly, the salinity profile, again, the interesting feature that we can see is from at Ghubra, where the desalination plant is, and we see higher salinities, although the difference is not much, but it's about 1 unit, 0.8 to 1 PSU. Which is like higher than the rest of the places. But in most of the places, as we can see, the salinity is within 36.6 to 36.7, about that range. Another thing is dissolved oxygen. As I mentioned, at some of the places we saw that the dissolved oxygen values are quite low. Most of the places it is about 6, which shows a healthy marine life, but the values which are less than 4, the marine life is under stress, and if it is less than 2, it is quite disastrous for the marine life. So we have seen in some of the places such type of situation is there, and most of these places where the situation is actually adverse is close to some of the coastal projects. Like Min Al Fahl, we have a very big refinery, and a lot of activity is there from coastal engineering point of view. For chlorophyll A, again, the interesting features are near Dukum, where we have higher chlorophyll A values, and we can see upwelling phenomena as well. Mostly higher chlorophyll A concentration is close to a depth of 10 to 15 meters below the sea surface. But here we have at higher elevations or at shallower depths, we can find higher value of chlorophyll A. And such interesting features also can be obtained from these measurements. Then some of the heavy metals and the petroleum hydrocarbons, which are shown here. Again, I'm sorry for the abbreviations used here for the stations, but there's quite a lot of data, so I wanted to show most of the things here. At Min Al Fahl, which is where the oil refinery is located, we can see that like the things which are there, like total petroleum hydrocarbon is higher near that area. And total petroleum hydrocarbon we measured in like different categories, like gasoline rate range carbons, then diesel range carbons, and then heavy fractions as well. But this is the total total petroleum hydrocarbon which is shown here. Otherwise, in most of the places, the values are less than the trigger values. And again, another topic of discussion is the trigger value, which is based on international organizations. We used a set of values from different organizations because we don't have that much detailed values for all the trace elements and the petroleum hydrocarbons in Oman.